All right, now let's look at the meaning of the derivative. Remember that in calculus, we know if you have a function, just one variable, then we know the derivative is the slope, right? Value is slope. But now we have two derivatives, two directions, in fact. So we cannot just say slope, but we still can think of that way. So let's just give it a try. And this time we're going to use the contour map or the level curves, because we know level curves give us the values of the function, right? And we can try. Let's look at f derivative in the x direction and 3 at 3 and 1. So x direction, that means y is a constant, right? Y is equal to 1. So what we are seeing is that, look at the y-axis is over here. So this one over here is y is equal to 1, okay? So now we know the following thing, that derivative at point 3 is approximately, we know, that's gonna be f3 plus some small thing, but 1 is still 1, and minus f3, 1, and divided by h, right? H can be both positive and negative, and h over here is small, approximately 0. So that's how we can estimate. So now let's go back to the graph and try to see. X is 3, y is 1, it's over here. So the value is over here. And we see that f3, 1, this value is approximately 14. You know where we can get this value? That's from this contour one over here. The contour is 14, right? Okay, now just let's move a little bit. What's gonna be f? Let's say we need to move x. So move to the right a little bit. Let's say we move to 3. This is 1, this is 2. Let's say move to 3.5, okay? 3.5, 1. Now, what is that? It's not there, but we can try to look at it over here. 3.5 and 1, so that's over here, okay? And, well, it's gonna be less than, it's gonna be bigger than 14, right? Because we know next one is gonna be 15, but it's close. So maybe 14 and half. Okay, so let's say 14.5. It's very approximate, okay? So now let's try to estimate the value of f of x, a partial derivative 3, 1, and that's gonna be approximately f 3.5, 1 minus f 3, 1, and divided by 0.5, right? That's how we approximate the derivative, and that will give us 14.5 minus 14 and divided by 0.5, and it's just 1. So approximately it's gonna be 1, and that's around this point. Now if you move to the left, you can also try, and maybe you can take an average. So over here, right? That's approximately 2.6, okay? So we see that f 2.6 and 1. 1 cannot change because we are moving on the x. And that's gonna be approximately 12, right? Yeah, it's approximately 12. So now we can also write down fx 3, 1 is approximately f 2.61 minus f 3, 1, and divided by, now it's gonna be 2.6 minus 3, right? So we're gonna have, here's 12 minus 14, and over here is negative 0.4. So here we have 2 over It's nearly 5. So what it means is that on the left-hand side, derivative is way bigger than the right-hand side. So we can even say, well, based on this is from right-hand side, we can put plus sign, negative sign over here. So fx 3, 1 over here, maybe it's just average of these two. It's just an approximate. It's not going to be a big deal because we are just trying to determine the sign especially. We know definitely sign is positive. The value is increasing along x-axis near 0.3. X is 3, y is 1. So if you put them together, that's going to be 1/2 and 5 plus 1. And that's going to be 3. Okay. I'll leave the other one for you to do. That's the vertical direction. Just give it a try to see what is the sign of the partial derivative with respect to y at the 0.31. And if you can, try to estimate the value. Okay.